going to just take one image and mark my diagram and kind of go off of it from there. So one of the first things that you know about, we're going to learn about these is that opposite sides are always congruent. Make a list here. Opposite sides are congruent. Opposite sides will also be parallel. So you'll see it with the little arrows as well. That's what those mean. It also means we also have opposite angles are congruent. And what I mean by opposite, this one and that one. Those are always congruent. Consecutive angles are supplementary. What's consecutive mean? Yeah, I'll go with that. So if you think of it this way, obviously I'm not going to label it always like this. Let's say this is A, B, C, D. Are A and B consecutive angles? Are they next to each other? Are B and C next to each other? C and D? D and A? Each next angle, they're next to each other like that. They're always supplementary, which means so they always add to what? 180. So A and B would add to 180. B and C would add to 180. C and D would add to 180. D and A would add to 180. A and C are equal to each other. They don't necessarily add to 180. Right? That's what that means. All right. And then diagonals bisect each other. And a diagonal is the segment that goes from vertex to vertex. It doesn't necessarily mean that the diagonals are equal. They just bisect each other. We'll start to get images like this. Now, as we go along into what we call the parallelogram family tree, you've got rectangles, squares, rhombuses, and all that kind of fun stuff. This is, all of those guys all have the same properties as these. They just have something a little bit more specific. That's where all this stuff comes from. Again, pretty sure most of this is stuff that you guys have all seen, and it shouldn't be anything crazy. So, opposite sides are congruent, opposite sides are parallel, opposite angles are congruent, angles that are next to each other are always at 180, and the diagonals bisect each other. And the part three. No, not yet.
Not yet. Did you go to Black Friday shopping? Did your wife go Black Friday shopping?
Yeah. I was at Target, and they didn't have any good deals. All they had was like, if you buy 5 things, you get one for half off.
Yeah, there was, honestly, to be honest with you, I know what our kids like, I know what our kids want, and throughout the year, if I see something that's a good price, I'll buy it. So there's most of the things we've had for them since for a while. You know, a couple of Lego sets that I found that were pretty awesome. Things like that. But no, I honestly, you're right. I didn't see anything that was really all that great. I'm trying to remember if I bought anything online.
I mean, Saturday.
It's all the same price always. It's just, it's non-stop.
Oh, it was just like $200 yesterday, now $100 then, and
It's the prices go up and down all the time. So, for example, here, guys. Oops. That was weird. One of the things we'll be able to do then is as we go through these things. What's up? Did you have a good break? Yeah, you good. Until I got sick this weekend. That's always fun. So as we go through these things, then we get to just use the properties and kind of go through. Now, when we said that what's that? One of the things that you'll see is just a matter of looking at what we're given here. They're telling you that the angle here at 64, and they're trying to find B. Is B across from it, or is B next to it? It's next to it. When they're next to, they always add up to equal how much? 180. So when you're next to it, again, that's kind of the idea here. If you break down the crazy vocab of consecutive into knowing that just means next to, and it works out pretty quick. What did you say it was? 160. Ooh, it's mathing hard for a Monday. What else? What other angle is 116? D. What's C then? We can pay this, isn't it? Let's start with that.
Pretty straightforward.
You know, I'm trying to help you out every once in a while. Can you guys see both of these all right? All right, pace yourselves and give those two a shot. You probably don't have to draw the pictures on most of these things. You can probably math it rather quickly without so much of a hassle. It's just a matter of, remembering what those are going to look like. I should draw them up here too. Were you guys busy at work over the weekend? I would imagine. All right, G. What was angle G? 48, good. Because G is next to or across from F. What about M? 6. Like I said, this is probably one of the easier things we do for a while. Yay.
That's nice. Wow. Ending the semester off with something easy.
Go figure, right? Every once in a while, we do have a decent thing to go. All right. Now, let's throw a little algebra in here. Oops, I don't even remember what that number was. Let's say this was 11. It kind of looks like an 11. So, are we dealing with angles or are we dealing with sides now? Sides. So, parallelogram then, with sides, we know that, what do we know about the sides? We know two things. They're congruent, which means they're equal, and then they're parallel. When I'm dealing with algebra stuff, are we really dealing with any parallel here? That really, parallel gets us to angles here, but when I'm dealing with sides, excuse me, it's just a matter of setting it up. So, deep breath. What's A? Okay, I'm sorry. Let's reframe the numbers here. I know. Yeah, 9. It's a lot. I know. What about B? Okay. I know mine does too. This is algebraically then. When we have the algebra here, remember opposite sides are always going to be congruent. So you know you just set it up algebraically. And we go from there. One of the things that I know that a lot of you guys tend to do is you think sides have to be 180. Just remember, that doesn't happen. I know, it happens all the time, man. It does. It's one of those weird things. So in this case here, what do you guys get for x and y? X is 2, good. What do you got for y? Add 5, you get? Yes, yeah. You add. Like I said here, this is pretty decent stuff today. Can we make this more difficult? I think we should have to make Now, this is where it can get, let me just pick one of these here. Well, that's fine, yeah. Now, it looks messy, and one of the things that happens a lot when they deal with the diagonals, you notice how You notice how the 9 and the 2n minus 1 are kind of the upper right part of the diagonal, and then the m and the m plus 8 and the 3m are on the other side. What they tend to do is they try to keep the sections of the diagonals in the diagrams. When they give you the numerical values, they tend to keep the two parts that go along together on the same side. Does that make sense? What I mean by the same side? See how these guys are both here and here, and those are there and there? That's kind of how they set those things up, so that way you can kind of see where the correlation goes between the two. Also, it's kind of obvious that the m's kind of have to go together, otherwise it's not going to math. Okay. So when you're dealing with diagonals, excuse me, they bisect each other. What does bisecting mean? Cut in half, which means they're finger on 3 equal. Good. So hopefully, when you did this, if you drew the picture, you made your little tick marks, knowing that those two parts would have to be equal to each other, and then you just set it up algebraically. So you had your 2n minus 1 was 9, and then your 3m is your m plus 8. Now I know you were complaining about getting more difficult. I added an extra step to your algebra. Well, I added a step. And it wasn't bad, was it?
Now we have to solve it?
Yep. So, if we do this correctly, what do you do first? You add 1, good. And what do you get for n? 5. All right. Same idea on the other side. Variables on both sides of the equation, you're going to pick up? Pick out the little guy, right? So you subtract the m coming back.
X equals 4.
Very good, very good.
Or, sorry,
That's okay. I do J.
Yeah.
Usually I use x's in a whole bunch of time anyway, so it's all right. Whew. I know. Let's do this one. Here, take a second, try this one then. Sorry, I kind of cut the picture up, but you don't really need the whole picture, I imagine. All right, take a second. Excuse me. And try that one out. And remember, if you're comfortable with this and you understand that the algebra here is just, since we know that those diagonals got bisected, there's nothing wrong with just writing the algebra straight out if you want to go with that. Go that route. It's okay.
That's how it's going.
What's that? Oh, I see what you're saying. Yeah. And then what do you do with that? Yeah, just move stuff around. That's fine. It happens. It happens. Hopefully you got that far.
Yeah. Right?
Now, one of the things that we've kind of done over and over again, so we always say pick on the little guy. If you picked on the little guy here, what'd you get on the left-hand side then? No, if you picked on the little guy, you move this over, what do you get on the side? What does it equal though? 0. Well, that's fine. Now what do you do? Now you can do this a couple ways. So, oops, you could have just done now, usually when I know that I'm going to get a 0 on one side, let me just use X real quick. I know in my head, if I move that 3x, because it's so ingrained in us to go ahead and just pick on the little guy all the time, if I know that I'm going to get a 0 on one side, I usually just do the opposite. I would have brought the 5 over, but But here's the only thing you have to be careful with. You have negatives now. So you just have to remember that that -9 comes down as a negative. Okay? Here you would have done the same thing. You added the 9 to come back over. You're still going to get the same answer. You guys get 4.5, right?
Yeah.
And that's fine. Because if I divide negative by a negative, it's always going to be positive. So it works either way. Depends on how you are, or if you're comfortable. Remember that you have the 0 to go there and just move other things. Or if you just disregard it, just go right for it. Either way is going to be just fine. And it's okay that you get decimals, guys. It's going to happen. All right? What was that? You probably did. You probably just didn't notice it. Because after you get going through most of these things, you just kind of, oh, it's just 0. It's fine.
Whenever it was like a problem like that, she always said, like, subtract
That moves you.
Yeah.
Yeah, and that's fine. Because then the only thing you just gotta be careful if you're doing that one, especially because of this, is just to rewrite it as a negative. And that's usually where students will make mistakes and they just forget that negative sign. Just a little. What I've seen in the past. And then the other side for solving for K, which should have been really easy. What'd you guys get for that one? You guys get 2? Good. Now, does it get weirder? Oh, quit your whining. Let's read it. So, one of the things that they'll do is labeling. So the first thing I want to show you is this. It says in parallelogram W, X, Y, Z. What do you think that's going to look like? So, does it have to be a square?
No, but it has to be like the four. Like that. No.
Maybe you have to label it W, X, Y.
Bless you. Where do I start with the W? Does it matter?
No.
No.
No. And that's what I wanted to show you guys. When they tell you something, it does not matter where you put the first letter. You just have to go in order. So if I call this W, the next one has to be
X, Y, Z.
We've done that before. Bless you. We've done that before when we just had triangles. If I said triangle ABC, you didn't know what it looked like. You just drew a triangle and labeled them in order A, B, and C. Same thing here. Since this is the parallelogram, and the way that we label it, we know opposite angles are the same. We know the opposite sides are the same. It's just going from the vocab of a, basically you want to call it a given statement. I don't mean proofs here. I just mean it's just giving us what it looks like. All right. Now, excuse me. It says W is 50 more than X. What does the word is mean? Angle W is 50 more than X. Is equals. You're getting ahead of yourself with the more. Okay? So what this says is angle W is 50 more than X. So if X is 10, what would W be? 60. So the idea is if it's 50 more than, it's 50 more than whatever X is. Okay? Everybody okay with these so far? All right. Now, what do I know about W and X? Are they what? They equal 180. They're consecutive. Right. So no matter what, if I add those two together, what do they have to equal? 180. Now, we
just do like one.
W plus. Well, hold on 1 second here. Hold on. You're getting a little ahead of yourself, Chris. It's all right. It's all right. So, as of right now, we know those two angles are next to each other.
Yes.
Okay, they're consecutive. We know that they have to be supplementary. We know they have to add the 180 because that's what all of that means. But here's the thing. When I write it out like that as W plus X equaling 180, I can't solve for two variables at the same time. But I do know that W is x plus 50. So W is x plus 50 plus x is 180. And that's where you were going. Yep. Yep. So what's x plus x? Because it says back here, W is 50 more than x. Okay, so wherever, what's called substitution. Wherever I see one, I can rewrite it as another. Two things are equal. Okay. Sorry, excuse me, what was that? So, what do you do now? Subtract the 50. Shh, guys, come on. Subtract the 50. Then what? Divided by 2, what do you get? So if angle x is 65, what do you do to figure out?
You add 65 plus 50 will give you W.
Yeah. So x is 65.
I had 130 and 60, but
I add 50 to it, and you get what, 115, I believe?
Yeah.
Okay. What other angle has to be 65? Z. And what's y then?
oh yeah.
And honestly, that's about as goofy as most of this stuff can get. You know, aside from just the simple 2-3 step algebra stuff as we go. Now, I'm sorry, excuse me. So let's see here. I think I have another one like this.
Give us a harder one.
Boy, don't give us money.
Now,
Show and tell.
hold on, guys, hold on. Now, in a problem like this, it'll say that ABCD is a parallelogram. Okay. It'll say parallel. Oops. So used to do triangles.
Well, stop talking about squares.
She's saying Martian. Get her. Because I draw down the square instead of doing the square.
Oh, yeah.
That's okay. Anyway, so it'll tell you that you have a parallelogram. Now, inside the parallelogram, notice what else do you see now with all those diagonals? Vertical angles and triangles, right? Uh-huh. So here's how this winds up working itself through. Now, in this case, excuse me, in this case here, you have the angle at DEC at 117. The vertical angle of that would have been at AEB. Is everybody okay with that? So right off the bat, you know that this side here is also 117. From that, you have two angles of a triangle of 117 and 23. How many degrees are left for that angle over that EAB? 40. Okay. Now, I can dump into this side now because 117 and that angle have to be supplementary, don't they? Yes, they do. Okay. So what's the supplement to 117? 63, good. So that gives me 63 here, which means on this side is also 63.
Are you right? I see what you did.
Now, 63 and 80 is how much?
63 and 80 is 6, 8,
143. Okay. If that's 143 between these two, how much is left for there? How much? Very good.
Yeah, you guys are so right.
All right. Now, here's where the parallel comes into play. Okay. As of right now, there's really nothing else that I can do to get moving to the other parts of the triangle, or to the other angles. So one of the things we have to remember is that when you have parallelograms, opposite sides are parallel, aren't they? Which means, isn't this a transversal? So if this is 23, what's this have to be? Which means this side is going the other way now. I go the other way. There's 40, which means this side is 40 here. Okay. Careful. Is this 80 part of that? 80 is not this whole angle here, is it? No, it's not. But I do know that this whole angle here has to be the same as this whole angle here, doesn't it? Which means that other side is, like you say, it's 80. It is because these guys, the big angle, I'm just going to call it big angle C and big angle A have to be equal to each other. Same deal with big angle B and big angle D. Those also have to be equal to each other. What's that? And that's kind of what it is symmetrical like that, and that it does work like that. Okay. If you get into it also because of the way that the triangles work, these two sides have to be the same. These two are the same. These guys. So if you start piecing around with that, you can get the way they correspond to the angles and all that work with congruency statements and stuff. And that's how it also should work. Okay. It kind of goes back into everything we've kind of done, even though it's a little different. It's still pretty stinking easy though.
I mean, now that
I mean, once you get going into it, it takes a minute or so. But as you start to see how it looks, it's not as daunting. And this goes back to the idea here. These questions. Oops. I must have skipped it. Oh well. But what happens a lot of times. Oh here. Notice I didn't even once look at the list of questions it asked me. Because that's what you do, yeah. This is the type of problem that you'll be asked. You know, you can ask a ton of questions off of one diagram just by doing that. Okay. Not too terrible?
Not too shabby.
All right. So last little bit of little things here today. And this, I don't know why they threw this formula in this section, to be honest with you. It's kind of a weird one to have here. It really doesn't, but what happens is, we kind of looked at this one before. Whenever you've got three parallel lines and two transversals. Okay. If you have three parallel lines and two transversals, if these two guys are the same, these two are the same. That's all it needs. And it's a weird thing they throw in this section. I think it's just one little algebraic problem they show us. There's actually a similarity statement that we do in chapter 7. Yeah, it's the first part of second semester that uses this a little bit more. But again, it's nothing too difficult. It's just one of those quick things that if you've got three parallel lines, two transversals, if the two on one side are congruent to each other, the two on the other side have to be congruent to each other.
I was so scared to fall asleep last night. I was running yesterday. Really, I was with my mom, right? No, for real. So then we were just playing food. And I just walked in there. And then, like, all of a sudden, you know, that moment when you see niggas in different dimensions? That's how my no, like, for real, like, we said,
Oh, yeah.
No, but, like, look, hear me out there. Like, that happened yesterday, right? That's all I remember. I don't feel like that. Now I'm waiting for you guys to say, are you okay? Yeah, I was so scared when she told me I had to sleep with her.
No, it's low resting heart rate and like low blood pressure. I mean, I had that too when I was in high school, where I stood up too fast, you get real dizzy. And,
But it wasn't even that, so like, that's the thing, I didn't even notice that. I got it for a while.
yeah.
And I just fell.
Did you grow? Did you get taller recently? I bet you got taller recently.
Bro, but that's
That's all right.
I was so scared I was asleep. I was like,
Oh, all you need is this. Are those three things parallel?
yeah,
Are these two segments equal?
yeah.
So what's that missing segment? Do those, please. You guys got a little bit of time to get started on it. Oops. All right. It should not be difficult whatsoever. Yeah. Please, by all means, I can grab a textbook if you want to take a picture of it and go from there. Yes, ma'am.
Oh, I have that.
That's all right.
Wait, are we choosing?
Everybody did. I think so.
Yeah.
Everybody turned it. All right, let me get you a textbook. You guys want to take a picture of it? I did not get a chance to put the PDF file on the calendar. I will do that now. You want to take a picture as well? We did a little bit of the bottom angle stuff. There should be a video on there for you.
I actually don't feel like I missed a lot.